So happy Tuesday. Some warm-up problems for you to do. Awesome. So arctangent of -3. So for arctangent, I'm looking solely at the right side of the unit circle. And so I need to be -3. Well, the tangent at this one would be -1/2 divided by the square root of 3/2. So that would be -1 over the square root of 3. That is not the negative square root of 3, so it's not there. The one here would be negative square root of 3/2 divided by 1/2. And that would give me negative square root of 3. That's what I want. So I want to say 5/3, but because I'm right side of the circle, and right side of the circle goes from pi/2 to -pi/2, this happened here, then I would have to say that that would be -pi/3. Yes? Yeah? Yeah? Sarah, thumbs up? Love it. Everybody else got the camera off? I can't tell. Okay. Cosine is top half of the circle, and so that goes from 0 to pi. -1 would be cosine is x, so that's out here, and -1, so this one would just be pi. Yes? Yes? Yes. Arc sine is right half of the circle again. -1/2, that one is right here. I want to say 11pi/6, but because it's right half, and we're going from pi/2 to -pi/2, that would be -pi/6. Agree? Love it. Okay. Good time. Last week, Friday, you should have been watched a video along with taking a formative assessment. Some of you still have to take that formative assessment. So would probably mean some of you still need to watch the video too. Okay? So there's more information out there that you should get done. But we're going to be doing more with composition of trig functions today. So we want to find exact answers, and we want our angle answers to be in radians. Okay? So, and we want our non-angle answers to be in exact fractions. Okay? So we want to be exact with all of this stuff. So, what I would do if I would have a composition is I start here on the inside. Okay? So I am going to figure out where the sign of whatever that blue value is. So I need to find the arc cosine of 1/2. So again, I'm looking top half of the circle. Okay? And I want to know where the x value is 1/2. And that happens right here at pi/3. So this would be the sine of pi/3. And then I would go back to the unit circle, and I would say, oh, well, I want to know what the sine of pi/3 is. Well, the sine of pi/3 is the y value at pi/3, which is just the square root of 3/2. And that is my answer, what I'm looking for. Make it look like a Christmas stocking. Clear this off. Now, second one. So, inverse sine of -√3/2. So, inverse sine is dealing with the right half of the unit circle. sine value of negative square root 3 over 2 is right down here. But it's not 5 pi over 3. It's negative pi over 3 because we have to stay within that negative pi over 2 to positive pi over 2 range of values. So this becomes the cosine of negative pi over 3. So I'm looking at, for the x value at negative pi over 3, and that would be 1/2. Agree? Okay. What I would like you here in the room to do, and you joining us via the interwebs to do, is I would like you to do these two problems, please. So we've got arc cosine of square root 3 over 2. So that's top half of the circle. That would be right here at pi over 6. So this would be the cosine of pi over 6. And the cosine at pi over 6 is just the square root 3 over 2. Which should be making lots of sense to us because cosine and arc cosine are inverse functions, and so therefore they should just cancel each other out, which they do. Okay? Inverse sine of root 2 over 2. So the sine of root 2 over 2, or excuse me, the inverse sine of root 2 over 2. So that would be here at pi over 4. So this is the sine of, oops, I put that in the wrong color. The sine of pi over 4, which is just the square root of 2 over 2. Again, they cancel each other out. Okay. I want to do one more just so that you guys see it. Let's try, we'll kind of do the same thing, but let's do an extra one. Let's do the inverse sine of the sine of negative square root 2 over 2. Actually, nope, that wouldn't work because I'd have to put an angle in there. Tapetal breaks. Let me put an angle in there. Sine of, let's go with, well, let's just go with 7 pi over 4. I love that. It's what I need to do. So the sine at 7 pi over 4 is going to be negative square root 2 over 2. So then this would become the sine, the inverse sine of negative square root 2 over 2. So then now I would look right half of the unit circle, and I would say, okay, where is the sine negative square root 2 over 2? Well, that's down here, but that would end up being negative pi over 4. So in this particular case, yes, the inverse sine and the sine cancel each other out, but we have to get it back in that range of the inverse sine. So we don't just write 7 pi over 4, we actually write it as negative pi over 4. Okay? Because that, we need to look that you might see. Another little tweak that you'll see is we're not going to always necessarily be on the unit circle. Okay? So we might be off of the unit circle, which is just fine. We can still handle that. So if I'm looking at the arc cosine of 4/5, that's going to give me an angle, and that angle is going to, let's just call it theta. Okay? So really what I'm looking for here is I'm really looking for the sine of theta. Now, we got to figure out where theta is. So let's draw ourselves a little triangle. Arc cosine is positive in quadrant number 1. So I'm going to draw myself a quadrant number 1 triangle. That's kind of a bad triangle. Let's fix that. I want to have Emmy yell at me. Okay. So here's my quadrant 1 triangle. This would be my theta then. Down here in that corner. Cosine is adjacent over hypotenuse. So we could fill those two in. And then a quick Pythagorean triple or using the Pythagorean theorem should tell us that that missing side is 3. Okay? Because 3, 4, 5 makes a Pythagorean triple. If not, we could have done 5 squared equals 4 squared plus y squared. 25 is 16 plus y squared. 9 is y squared, so we get 3 out of that. Yeah? Okay? So I need the sine of that angle theta. Well, the sine of that angle theta is going to be the opposite over the hypotenuse. I've now found my opposite side. It's 3, and my hypotenuse is 5. So I don't need to actually find the actual angle that I'm looking for. Okay? I can just use it kind of as a rest stop, a waypoint on my journey to get the answer. Okay? Try another one here. Cosine of the inverse sine of 5/13. So the inverse sine of 5/13, that's going to give me my theta. Sine is positive in quadrant number 1. So again, I'm going to draw a quadrant 1 triangle. This time, however, theta is going to be there. 5 is my opposite side. 13 is my hypotenuse. Sine is opposite over hypotenuse. Which then that's going to give me a Pythagorean triple of 5, 12, and 13. Again, if you didn't know that, we could always have done 13 squared equals 5 squared plus x squared. 169 equals 25 plus x squared. 4 is x squared. That's where we got the 12 from. Okay? So this is the cosine of theta. Theta I've got marked there. That's awesome. Cosine is adjacent over hypotenuse. So that means then that this is going to be 12 over 13. Questions on that? Hearing/seeing, none. Why don't you now try 2 of them? Do this. All right. Our cosine is negative now. That puts me in quadrant 2. So I'm going to draw a quadrant 2 triangle. Cosine is actually comes all the way over here. Okay. So cosine is adjacent, so this one would be -8 over hypotenuse, which would be 17 there. And then I need to figure out that I believe this ends up being 15. 17 squared is equal to -8 squared plus y squared. 289 equals 64 plus y squared. 5 is y squared. So that's 15. Okay. So I need the tangent then. Of my theta. Move. Tangent of theta. So the tangent then is going to be the opposite side, which is going to be 15, over the adjacent side, which is -8. -15/8 there for that one. Yes? Yeah. Love it. The secant of the arc sine of that one. All right. So this arc sine of -5 over 13 is in quadrant number 4. Arc sine is negative down there. So that would put my theta all the way around there. Sine would be -5 would be there. 13 would be my hypotenuse there. We already did that one. That's a 12 then. Yeah. So this would become secant of theta and theta. So secant of theta, that's what? 1 over the cosine of theta. The cosine of theta is going to be 12/13 because we're in quadrant number 4. The cosine is positive there. So the reciprocal, or 1 divided by 12/13, is going to be 13/12.
Mr. Insmeyer,
What's up?
does it really matter how you draw your triangle if like it's still set up pretty much the identical way?
The only reason that I do it that way is because then it's in the quadrant that I know it's supposed to be in, and that tells me if, because if my in like number 8, that triangle tells me that I'm in quadrant 1 or quadrant 4. So if I'm in quadrant 4, then sine is negative, tangent is negative. You know what I mean?
Yeah.
It's kind of, but yes, you are correct. It doesn't matter how you draw your triangle,
So I
but
just have to see it more.
yes, it helps you
Okay.
remember that, I got to have this one be positive, negative, et cetera, et cetera.
Okay, thank you.
Yep, nope, not a problem. Everybody else good? Love it? Okay. Then the other kind of problems that we have are more algebraic type of problems. Okay? And those are done the same way. Okay? So I would find here the value of my cosine. So again, now I would make my triangle. Cosine or arc cosine is positive in quadrant number 1. So we're there. And so my theta is here. Cosine is adjacent, so that's going to be the 3x, and my hypotenuse is going to be 1. because it's 3x over 1, so 3x is the adjacent side, 1 is the hypotenuse. But now I've got to do some math here now. So 1 squared is going to equal 3x squared plus y squared. So that's 1 equals 9x squared plus y squared. So I subtract 9x squared, and I square root it. So that is this side up here, and it is also positive because I am in quadrant number 1. I don't need the plus or minus there. So I'm really looking here for the sine of my theta, and the sine of my theta then is going to be the opposite side, which is going to be the square root of 1 minus 9x squared over the hypotenuse, which is just 1. So I could just write this as the square root of 1 minus 9x squared. Agree? Questions? Let's try another one like that, where we get some algebraical type ones. So we've got the arc cosine of 2x, positive in quadrant 1. Sine is opposite over hypotenuse. So then we've got 1 squared is equal to 2x squared plus y squared. So 1 equals 4x squared plus y squared. Subtract 4x squared. Square root. And that, the positive one, is going to be here. So this is then the cosine of theta, which is going to be the adjacent side over the hypotenuse, or simply put, just the square root of 1 minus 4x squared. Love it? Love it. Try those two on your own. In quadrant 1, we got theta, we got x, we got 1. If we follow the same pattern, then this is going to be the square root of 1 minus x squared. Okay? So we want the secant of theta. So the secant, what's up? Oh, yep, it should be on the bottom. Yep, I got those switched around. Still the same math. Okay. Good catch. Okay. So we got that. Okay. So secant is 1 over cosine, correct? And the cosine of theta is x over 1. So just x. So this would just be 1 over x. Yes? Yeah. Theta again here. X there now. I was looking at that one, the last one. Okay. So then same math. 1 minus x squared there for that one. So I want the tangent of theta. Tangent of theta is going to be the opposite over the adjacent. So that is going to be the opposite side is x. The adjacent side is square root of 1 minus x squared. And for terms of these problems, we'll leave these funky fractions. We won't have to rationalize the denominators. We can just leave them like that. Okay? Love it? So a couple of things now. That was the last example that I wanted to do. A couple of things for over break, because this is the last class before break. Group A students, your unit circle project you can bring in, or we want you have those brought in by January 8th. Okay. Group B in-personers, we extended that deadline to the 12th for you, so you don't have to come in separate just to bring in your unit circle project. You can bring it in that Monday or that Tuesday of that. Okay? But January 12th is the day that we are going to grade them, so if they're not in by January 12th, sorry, no dice. Okay? Also, there's a few people that still have to do the formative from last week, so get that done. I've got some people in my classes that have lots of things that are missing yet. So those things can be worked on as we go forward with these kind of things. I will stay in the group chat for the rest of the class if you have any questions or you need some clarifications on some stuff. But otherwise, that's all I got for you. Thanks for playing along. Have a good day. Have a good break.